Hello, this is part 2 on a series for GCSE Maths Trigonometry for Triangles. Here we will focus on exact angles, tan-sine relations, non-right angled triangles including the sine, cosine and area of a triangle, and we will go through some harder practice problems at the end. At the end of this lesson you can go down and see the practice questions and you can try them out. The answers will be at the bottom of the sheet. If you're still unsure about your foundations, right-angled triangles and SOHCAHTOA, then you can go in the link in the description to see part 1, where all of that is explained. Okay, let's get into the video. If you're still here, you are a higher student. There's a relation between tan and sine and cos. So you might have seen before that tan theta equals sine theta over cos theta. But let's try and understand why. Let's write out what tan theta is in terms of the sides. So tan theta is equal to O over A, right? And sine theta, as we've written before, is equal to the opposite over the hypotenuse. And cos theta is equal to the adjacent over the hypotenuse. Let's put a theta there. Now, let's just start from this equation and show that indeed it is true. So tan theta equals opposite over adjacent. Well, that should be sine theta over cos theta. But let's break down what sine theta and cos theta are made of. That would be opposite over hypotenuse divided by adjacent over hypotenuse. Well, the hypotenuses cancel if we know our rules of fractions. So we can just cancel this one and that one out. And look at that. We end up with indeed opposite over adjacent as what tan theta is defined as. With this, it's a relatively simple understanding that tan theta is just a composite of the other two. And now that you know that, I hope you don't forget. Now, unfortunately, there is also some memory that might be asked of you. You're going to have to remember the sines, cosines, and tangents of several key common angles. We can visualize the common angles that we might see. First of all, 45 degrees, as we might expect, is quite a common angle. And you can see that with Pythagoras, these two sides will give us a side length there on the hypotenuse of 1. Similarly, if we have another hypotenuse 1 triangle, and we draw 30 degrees and 60 degrees, we'll get an opposite of a half and an adjacent of root 3 over 2. Just visualizing these triangles, we might be able to understand the angles that I will describe in this table below. So, a very common way to remember the exact angles is to write a table like this. What we then tend to do is we tend to put a divided by 2 sign on each of the rows. Then we put a square root on the top number. Now, what we need to do next is we need to put our numerators in. For sine, we just start counting from 0 degrees at 0. So 0 here, 1, 2, 3, 4. For cosine, we count down from 4. 4, 3, 2, 1, and 0. Now you might notice that these angles actually simplify quite nicely. This will just be 0. Root of 1 is just 1, so that's a half. This root 2 over 2 you might sometimes see as 1 over root 2. I'll let you try and figure that one out. Root 3 over 2, not simplified, but the 90 degrees, root 4 is 2, that one just equals 1. And we can do the same for cosine. So you might notice that the sine angles and the cosine angles are exactly flipped. 0 degrees is equal to 90 degrees. And 30 degrees is equal to 60. And the 45s are the same. That is another pattern that might help you remember these. In the end, there is only a few numbers you need to remember. 1, 0, 1/2, root 3 over 2, and root 2 over 2. As we can see, the values that get given there. Now, if you visualize it, it might help you. Sine of 0 degrees is going to be 0. Why is that? Well, let's say we take this as our angle and we reduce it to 0. What happens to the opposite? The opposite also goes to 0. And sine is opposite over the hypotenuse. So sine of 0 should be 0. You can use similar logic on triangles like that if you want. Now, why have I not included tan here? Well, by now we should know that tan is equal to sine divided by cosine. So we can actually just use our memory of the sine and cosine angles to find tan. So we'll never have to remember the tan angles, only the sine and cosine, and that will make it easier. So what are the tan angles? You can give it a go here before I show you the solution. Okay, so sine divided by cosine, 0 over 1, 0. 1/2 divided by root 3 over 2, 1 over root 3. You can also write this differently. Here we just have the same, so tan 45 is just 1. We have root 3 divided by 1/2, that'll just be root 3. And then 1 divided by 0, well, we can't do that. There is no value of tan 90. And perhaps that should make sense. We have a right-angled triangle, right? And then we want to find 90 degrees on the other kind of angle that we don't know, right? And tan is our adjacent, which would be over here to our angle, theta. And this would be our opposite. So what's the ratio of the opposite over the adjacent? Well, if we just increase this angle to 90 degrees, it doesn't really make sense anymore. It's not a triangle. So it should make sense there's no value. Finally, we have the graph method. And this is personally my favorite because you will be using graphs more and more in the future in trigonometry. So this will become more and more intuitive to you if you can figure out the angles using the graphs. The first thing that we need to know is that y equals sine x looks like this, and y equals cos x looks like that. And then we can immediately see some of our key angles. 0 degrees on the sine x is 0, indeed, as it says on the table and as the graph supports. And 90 degrees over here will be up there at the 1 value, which our graph supports. So you can do the same thing for cos. Cos of 0 degrees is 1, and 90 degrees is where it crosses the axis. And we can remember them just from the shapes of the graph. Now, what about the 30 and 60 degrees? Well, there are two values that they can have. You might have noticed they can either be 1/2 or they can be root 3 over 2. So let's draw the line of y equals 1/2 and y equals root 3 over 2 on top of these two lines. So I've drawn the two lines on our sine graph. Remember that root 3 over 2 is a number that is slightly less than 1, equal to around about 0.87. So this is the line y equals root 3 over 2. And then this is the line y equals a half. Now where these lines cross the sine axis is where we'll get sine x equaling to a half, or sine x equaling to root 3 over 2. The first point is here. So this point will tell us that sine x equals a half. Then this point over here will tell us where sine x equals root 3 over 2. Now, the only other two angles that we're dealing with are the 30 and the 60, and they can take either this value or that value. So which one is 30 and which one's 60? Well, we have two values that it can be, a smaller one or a bigger one. Clearly, the bigger one is 60 degrees, and the smaller one is 30 degrees. And so we can see that a half is 30 degrees, sine 30 will be a half, and sine 60 will be root 3 over 2, just from the positions of these two intersection points. Now, the 45 degrees is one that perhaps you just have to remember. You could also draw a line in between for the root 2 over 2, which will be somewhere in between a half and root 3 over 2. And then you'll be able to see that the 45 will sit somewhere over there. Now I've done the same thing for the cos graph. And here you can see that root 3 over 2 roughly coincides where 30 degrees would be. And 1/2 would coincide where that 60 degrees would be. And just a rough sketch in the side of your paper of these two curves while you're trying to remember the angles might help you understand which one is the 30 degrees and which one's the 60 degrees of the sine and cos. And of course, the 45 just lies in between, so that should be root 2 over 2, which is the value in between that we have to remember. All in all, you can use 1, 2, or all three of these methods. As you try it more and more, it should become second nature. Me personally, I use the graph method. I visualize the graph in my mind if I'm not sure. And as you do these questions more and more, that might be the same for you, or you might prefer to visualize the table. It's up to you. Here are the tools. So now, non-right-angled triangles. The first thing that we need to know about triangles that don't have a right angle is that we can no longer use the opposite, hypotenuse, and adjacent kind of notation because those sides just don't exist. There is no right angle to compare everything to. Instead, we use a kind of ABC notation with lower cases representing the sides and the uppercase letter the angle opposite to each of those sides. So remember, lowercase are sides and angles opposite uppercase are the angle opposite that side. And it also would do you well to remember that we always need three pieces of information to figure anything out in a triangle. That could be three sides, like ABC, that would be SSS, or a side, an angle, and a side, meaning that we have perhaps two angles AB here and a last, two sides AB and the last angle C. Or we can have a side and two angles. So two angles here, perhaps a side there, or anywhere else. Any position of these three pieces of information will allow us to figure out the rest of the triangle. The triangle is just defined by three pieces of information. Note that if you have all three angles, you can definitely figure out the ratio between the lengths of the sides, but you'll never be able to figure out the exact length, because you can imagine with the same three angles we can create a triangle that's a kilometer long or one that is a centimeter long, and there is no restriction on that. So 3 sides, 2 sides and an angle, or a side and 2 angles is what we need to figure everything else out. Now let's get into the 3 rules that we can use with non-right angled triangles. The first is the sine rule. The sine rule is when we have a pair of opposite angles and sides. So something like this. Now remember, we only need 3, so one of these must be our unknown, and the other 2 can be known. And you can actually prove through using right angles by drawing a triangle of such a manner with a right angle like it through like this, that sine A over A equals sine B over B. And of course you can extend that to sine C over C, but I'm just keeping it these 2. Of course, if you do the inverse, like 1 over both sides of this equation, you might see the equation in this form. They are just the equivalent equation. Now, I will not be going through the proof because it's not necessary in order to be able to use this sine rule. So how do we use it? Well, let's draw a triangle. Any triangle will do, so I'm just going to draw a random triangle like this. Now, if we have, let's say, an angle here, 30 degrees, and let's say we have the opposite side of that angle is 15. Yes. Now, imagine that we wanted to find this angle here. If we want to use the sine rule to find that angle, we need another piece of information. We will need this side over here. So let's give that side a value, say 10. And now we want to find x over there. So we're dealing with angles and opposite sides pairs, like so. And this is ideal situation for our sine rule. All we need to do is fill in the values. It doesn't matter which we choose as A and B or C. One of them is. Let's call this angle A. So sine of 30 is divided by the side opposite it, 15, should be sine of x divided by the sine opposite to it, 10. And now we have an equation that we just need to solve. Make sine x the subject, which will be 10 over 15 sine 30. And then you can calculate that, which will give you 1/3. So sine x is equal to 1/3. Then we can do the inverse sine, and we will find that inverse sine of 1/3 is equal to round about 19.5 degrees. Of course, this is quite a straightforward example of the sine rule. Later on, we will be doing mixed questions, and they can definitely get harder. Note that this equation will most likely be in your formula sheet, so you won't have to remember it. Don't worry about that. Okay, so that was it for the sine rule. Now let's have a look at the cosine rule. Okay, so the cosine rule. The cosine rule has this equation, which is probably the most complicated one that you'll be using in GCSE Maths, but it's not as scary as it looks. First things, we need to know what it applies to. And generally it applies to this kind of formation where we see 2 sides with an angle sandwiched in between, and then we have that opposite side as well. And remember that we only need 3 of these pieces of information to figure out the fourth. So you might be given all 3 sides and you want to find an angle. And you can use all 3 sides to find any of these angles. Just change the name of A and B. For instance, if this is the angle that you want to find, then we can call this one A, and we can call this B and C, and that side A for our formula. And likewise, you can do the same on that side. The orientation doesn't matter. So if you have all 3 sides, you can find any angle you want with the cosine rule. Just remember that A is the side opposite the angle A, capital A, and the other 2 sandwich that angle. And of course, if we have an angle and we have 2 sides sandwiching it, we can easily find the opposite. So there are many combinations, but the more you practice, the more it will be clear which rule you have to learn. So let's try an example question. I'm going to draw a random triangle, and now I want to ask, what are the sides of all of these angles here? Let's call this angle X, that angle Y, and that angle Z. How are we going to use the cosine rule to do this? Well, first we need to choose which angle we're going to start with. I'm going to say X. And then what we're going to have to do is we're going to have to label all the sides relative to that angle X. So remember, A is now our X, all right? And that means that the sides sandwiching our angle X, 11 and 20, are our B and C. It doesn't matter which one's B or which one's C. And that means that 12, the side opposite to X, is our lowercase a side. Now that we've labeled all of our values, we can pop them into the formula. So let's try that. A squared equals B squared plus C squared minus 2BC cos A. And now let's substitute the values that belong to each of these quantities. 12 for A squared is equal to 11 squared for B plus 20 squared for C minus 2 times 11 times 20 times cos of our angle that we want, X. So cos X. And yes, this is a big formula, so you will have to be comfortable with rearranging these kind of equations. But let's do that step by step. Remove first the further terms, so we get 12 squared minus 11 squared minus 20 squared, subtracting both of those, equals minus 2 times 11 times 20 cos X. Now, we can just go ahead and divide by this entire thing to get cos X on its own. The minus sign, you might want to do something about it, but I'm going to just divide the minus as well, just to keep it simple. So 12 squared minus 11 squared minus 20 squared divided by minus 2 times 11 times 20 equals cos X. And now if we want X, we just do inverse cos of all of that. So X equals inverse cos of 12 squared minus 11 squared minus 20 squared divided by minus 2 times 11 times 20. I do suggest that if you're using a scientific calculator, you get used to using the fraction button on your scientific calculator. The fraction button automatically replaces the need for you to put brackets and a division like this. And you can just write directly what you see on your workings out on your piece of paper into your calculator. So the fraction button is very powerful. Try and get used to using it, and it will make all your calculator work quite easy. Putting this value into the calculator, you'll get that x equals to around about 31 degrees. And there we go. We found that x equals 31 degrees. Now, we could repeat this process to find z and y. If you want to find y, all you have to do is you need to relabel your sides. So from y's perspective, y is now a in our formula, and these 11 and 12 are now bc, and this will be lowercase a side. And you can repeat all the working, and you will get that y is equal to 121 degrees, which you might expect. 20 is the longest side. The greatest angle should be opposite that. Okay, I hope you managed to get all of those right. If you didn't, please write to me in the comments and we can see where you've gone wrong. Now, that's the cosine rule, a long and tedious formula, but a very powerful tool, as you can see. There is one more formula on non-right-angled triangles that we should learn, though, and that is the area formula. The area formula allows you to find the area of a triangle if you have an angle sandwiched by two known sides. Now, just looking at the blue lines here, you can see that this black line over here doesn't really matter. We have enough information to find the area enclosed just from the blue quantities here, the angles and these two sides. This is specifically a side angle side rule, and the area is equal to 1/2 AB sine C. Let's go through an example question. Can we find the area of this triangle? Feel free to pause the video and see if you get the answer right. So, as with all the formulas, we just have to identify which quantities are which. Here it's quite simple. B and A are these two sides, and our angle is 25, which is C. So our area is equal to 1/2 times 13 times 9 times sine 25 degrees. And if you put that into a calculator, you will get 24.7. Now, not all the questions are going to be this simple for finding the area. For instance, you might be given this last side. Let's give it a value of 6, and we might not be given the angle at all. In that case, now if they ask for the area, we first need to find an angle. And we need to do that using the cosine rule that we've seen before. Then, when we have our angle, we can find our area using this formula. So you can see that questions can get hard by mixing the use of all the different formulas that we have. So, to summarize, we've gone through the theory of right-angled triangles with SOHCAHTOA. We understand that tan can be related to sine and cosine. We understand how to remember exact angles, and we understand the formulas relating to non-right-angled triangles. I am now going to go through some harder mixed style problems that can use any of these pieces of theory. Before I go through the solution of each of these problems, feel free to pause the video and try it for yourself. Okay, let's have a look at the problems. Okay, so the first problem is this one here, and it comes straight from a paper. Feel free to pause the video here and try it yourself before I go through the solution. So we want to find x. Now notice x belongs to two triangles. It belongs to this one over here, and x also belongs to that one over there. In both of these triangles, they're right-angled and we have the other angle. That means that if we find any of these sides, say this one here, or this entire length there, then we can easily find x using SOHCAHTOA. I will use this triangle here. First, we need to see that we have one angle and one side, and that's not enough to find this side here. That will let us use SOHCAHTOA on the bigger triangle. So we need another angle, and that's where this straight line comes in handy. If we know that the angles on a straight line add to 180, then we can show that this is 126 degrees. And this one, the interior angles of the triangle, will be 26 degrees. Now we can use one of our rules, either the cosine or sine rule. In this case, the sine rule will be easier, because we have a side and we have an opposite angle. And we have this angle here, and that's the side that we want to find. So, labeling those sides according to our sine rule, we would get that, let's say this is side A, and that would be angle A. This is side B, and that would be angle B. And so sine A over A equals sine B over B. Substituted in, we get sine 26 over 25 is equal to sine 126 over our unknown, and I'm just going to call it B in this case. Now, to find B, we can rearrange this equation. We can multiply out the 25 and the B and divide by the 26. Hopefully you are familiar with rearranging these kinds of equations. Doing so, we will get that B is equal to sine of 126 divided by sine 26 times 25, which will give us 46.1. So this side is 46.1. Now we can draw a triangle that includes x and that side, the right angled triangle. So this greater triangle here is this one. And notice that that is just a triangle like so, with x on this side, 90 degrees there, 28 there, and 46.1 here. And so we can just use our standard trigonometry. In this case, we have the opposite and the hypotenuse. So we will just write that sine of 28 is equal to x over 46.1, and that will give us x equal to 21.6 with some rounding. And there we go, we found x. There are alternative paths. You could try and find this side here instead. Or you could try and find this side somehow and get that total length. You could try them out yourself if you want. Okay, on to the next question. Simply, we have three sides and it's a random triangle. We don't know if there's any right angles or not. and we're asked to find the area of the triangle. Now, I've hinted at this one before, so feel free to pause and try it yourself. Okay, on to the solution. So as I've said, in order to find the area of the triangle, we need to use that sine area rule. So our area is equal to 1/2 AB sine C. But in order to use our area formula, we need an angle. And in order to get an angle from this, we have to use the cosine rule. So we need to use a squared equals b squared plus c squared minus 2bc cos A. So let's try and find an angle. I'm just going to choose this one here. Now, this is just a repeat of the cosine rule questions that we did earlier. So I will skip that working, and I'll just give you that the answer to that theta is equal to 41.65 degrees. Okay, now we have that angle, 41.65 degrees. The second step should be relatively straightforward using the area formula. So our area is equal to 1/2 times 12 times 15 sine of 41.65 degrees. That will give us 59.8. And there we go, done. If you're confused at how we found this angle, please go back to the cosine workings that we did just before. You'll see an almost exactly the same problem. Okay, so this is the last problem, and it's a very tricky one. Because we have this triangle, and we have two sides with x and 2x minus 1, and some angles like so. And we're asked to find the area of the triangle. But I mean the area, not the area in terms of x, the area itself. It's a whole number. So if you think you can do it, feel free to pause here. I'll give you a hint. You should try and find x first, and then you can find the area. Okay, so the first step is to think, how are we going to find the area? Well, as we've seen before, there is the area of the triangle formula. So our area equals 1/2 AB sine C. Now, if we have two sides that are sandwiching the angle, then we can find the area. And we do have these two sides. We don't have that one. So it'd be good if we can find that angle. And that angle you can calculate will just be 180 minus those two, which will give you 105 degrees. But now we have a problem. We don't know what x is, and we don't want to find the area in terms of x. But maybe we can just write it down anyway. So 1/2 times x times 2x minus 1 times sine 105 degrees. Okay, great. Now, if we can find x, then we can find the area. So how are we going to find x? Well, the trick is to notice that we have two sets of opposite angles and sides, and so we can use the sine rule. So the sine rule will say that sine of A over A is equal to sine B over B. And now we can just fill in the two values for this. And so what we will get, sine of 30 over x is equal to sine of 45 over 2x minus 1. Now, this is an equation, and x is our only unknown, so we can find x. And I can leave it to you as a challenge. You don't need a calculator either, because these are exact angles that you should try and remember. So feel free to pause here and try and find x. Okay, so the first thing that we do is we multiply the x to that side, and we multiply the 2x to minus 1 to that side. And doing so, we'll get 2x minus 1 sine 30 is equal to x sine 45. if you've remembered your exact angles, you'll know that this over here is a half, sine 30 is, and that will be root 2 over 2. And so we can simplify it. So 2x minus 1 times a half equals x times root 2 over 2. Now expanding, the x minus a half equals root 2 over 2x. Now we bring the x's to the same side, and we can bring the minus 1/2 to that side by adding. So we get x minus root 2 over 2x equals a half. Now, in order to solve this, we need to factorize. So we take the x out, 1 minus root 2 over 2 equals a half, like that. And then we just need to divide through by this whole thing. So, doing that step by step, 1/2 divided by 1 minus root 2 over 2. And the half can come to the bottom. So 1 over 2, 1 minus root 2 over 2, like so. And then we can expand that, and we'll get 1 over 2 minus root 2. And if you put that into a calculator, you get 1.71. You could have put it into a calculator at any moment, but I just wanted to show you all the steps. So x equals 1.71. Now we have that value. So we know the lengths of these two sides, and we figured out the area in terms of x. So we can just substitute it. That equals 1/2 times 1.71 times 2 times 1.71 minus 1 sine 105. And if you put that into the calculator, you will get 1.999. And there we go, we found the area. So that was a very tricky one. Well done if you got it. Remember that there are extra questions of this style in the description. So I've made a PDF sheet that you can try with lots of questions on trigonometry for triangles. So give it a go. And that's it for today. Have a good day. Bye.